This is 1R2S4S trichlorocyclohexane, and this molecule is 1S2R4R trichlorocyclohexane.
Okay, now we're going to show the lowest and highest energy conformations of 1R2S 4S trichlorocyclohexane. As you can see here, this is the trichlorohexane in chair formation. This is the lowest energy formation and also the most stable formation. As you can see from the positioning of the atoms, there is no angle or torsional strain, but there is some small steric strain. Now, we flip this and it becomes the boat position. This is the highest energy conformation. As you can see from the model, it has small angle strain. However, it has a large amount of steric and torsional strain, thus making it less stable and higher in energy. So now we're going to talk about how the chair conformer, shown here, and the boat conformer are related to each other. These two molecules are related to each other in the sense of diastomers. This is due to them not being mirror images or superimposable. Okay, now we're going to go over which chlorine atoms are occupying an axial or equatorial position. Looking at our molecular model here of trichlorocyclohexane, we can see that this chlorine is axial, and while these two are in equatorial positions. This is carbon number 1, carbon number 2, and this one is carbon number 4. Now we are going to go over the cis and trans relationship of each chlorine atom on this molecule. And so the first is the chlorine on the first carbon and the chlorine on the second carbon. These two chlorines are in trans relationship. It is because the chlorine on the second carbon is in axial position and the chlorine on the first carbon is in equatorial position. Now for the chlorine on the second carbon and the chlorine on the fourth carbon. These chlorines are also in trans position. This is due to the chlorine on the second carbon being in axial position and the chlorine on the fourth carbon being in equatorial position. The relationship between the chlorine on the first carbon and the chlorine on the fourth carbon are in cis. This is because they are both in equatorial positions.
This molecule now is 1S2R4R trichlorocyclohexane. Looking at the first carbon, we have a chlorine in the axial position. Looking at the second carbon, we have a chlorine in the equatorial position. And looking at the fourth carbon, we have a chlorine in the axial position as well. Now, comparing this molecule to the initial molecule seen previously, these two are related because doing a ring flip on the first molecule gives us a superimposable result. Looking at 1R2S4S trichlorocyclohexane and 1S2R4R trichlorocyclohexane, neither of these are meso compounds. This is because no matter how you twist the bonds or rotate them, there is no plane of symmetry. Meso compounds are achiral compounds that have a plane of symmetry, and because neither of these have that plane of symmetry, therefore they're not meso compounds.